we are starting the second block for today, which will cover the advanced predictive models, which assumes econometrics were simple predictive models. But you know it's not. I hope you know that this is not the case. There are different use cases for both. But I guess when we say predictive modeling, we usually think machine learning. So that's basically what we will cover in the second part. Just for the starters, I already have the Jupyter launched, but you should go to launch the notebook as on the previous session and the yesterday 2 sessions, and go to day second B and open the MLJ notebook. We'll have some additional files here. We will actually use the TXT in a second, but the MLJ notebook is the crucial one. Okay, so just from the, let's say, organizational things, I will for the question and comments on the chat, I will actually, after, let's say, bigger sections, I will check it during the I will switch to Teams and check it. And of course, from the classroom, you know, feel free to go as you please with the questions. And I think we can move to the content. We have 2 hours for that. And just so that's a little longer than the let's say regression part. So just to structure it, I will start with some explanation what actually we will do today, because saying okay we'll do machine learning is probably like yeah, that's you know, you can have probably a university doing machine learning, or the department, yeah, like you have computer science, yeah. So I guess I also was by the cafeteria and saw some nice posters with Jeffrey Hinton, right? I remember the surname correctly, and then there was a lot of stuff with deep learning and meetings with famous people. So I guess that's what you do here a lot. But to be exact, then, yeah, I just want to show MLJ, which is machine learning in Julia. And yeah, I think you know, it's my assumption is that you know a lot about machine learning, so I don't want to explain what overfitting is and so on, but maybe you don't know MLJ, and this is like a framework. I guess it's a package, but the size of the framework for structuring and doing machine learning in Julia. Basically, that's the name of the package. So that's my main focus, but I also want to start with some overview of machine learning process, in the sense that maybe we just to set the boundaries, because I think the definition changed between, like, each year it's changing, I guess. Right now, if you say machine learning, probably everyone is thinking machine learning operations, or right now, yeah, explaining the machine learning models. So explainable AI, or sorry, actually that was already it's like old stuff, because now everyone is about LLMs and ChatGPT and this stuff. So probably what I'm saying is already obsolete, or maybe not hot anymore. But I want to set, yeah, I want to go through this nice diagram from Andrei Burkov. I like the book really much because it's from ML engineering, and maybe I will pick some blocks. I will pick some blocks and say that what we'll cover with MLJ. And that's the first part, and then we will basically go through different parts of MLJ, because, as I said, it's a framework, so it has a few modular moving parts which fits nicely with Julia. And of course, yeah, we will use some data sets, so I also want to take a look what we have. Okay. So I think like using MLJ basically will be, you know, like, we'll have some pre-processing, and we'll end with hyperparameter tuning, but I don't think we need to cut it into those small pieces. We'll just follow the process. So when it comes to machine learning process, I think yeah, now it's every year it's changing. Yeah, so I guess we are reaching a moment in few years that machine learning models will do machine learning themselves, and then it will be a different process. But if, for example, if we go a few years back, I guess it was like, okay, so you have a data, something clean or not clean, usually not, and then you want to do machine learning, and then you build the models or model one of them. In the end, everyone is happy, but the model doesn't go to production, yeah, because then the problem starts. So like a few years back, I guess we had much less like infrastructure, like the cloud related, or even package on your laptop that you can use to launch the stuff you built and evaluate. And usually this was not aligned with the like there was not a really well thought business process. So I would say that in this diagram, this machine learning was basically starting at data collection and preparation and at model evaluation. So not much business value. I guess that's fine. And yeah, I guess also we were like, if we go back even more, then we are machine learning is in academia, yeah, and then that's where it ends. You don't need to implement that, or like you want to, but actually moving from academia to business use cases is a long way. So at some point someone noticed that probably we want to deploy those models, so they are serving someone and doing the stuff they are intended to do, and also intended to do is quite not straightforward. And then we had those MLOps stuff. We had like AutoML and everything in the cloud. We still have, but I guess right now everybody is thinking about LLMs, and we want to use those large language models everywhere and for everything. So I will not cover that, but we will do what we'll do, some random forest, so old stuff, but basically right now I think we are quite good with those models. And if you go to any bigger portal on internet, then they have those machine learning models serving someone. So if you go to Amazon, you have recommender systems. Yeah, if you go to I guess recommender systems are the easiest to find, yeah, like in Spotify or Amazon and everywhere. But yeah, now you have also those LLMs that help you learn stuff, let's say, or write stuff sometimes. So it's working and it's useful, and I think we have much better, starting from the beginning, the business side and the goal definition is much clearer in most of the cases. So actually, Andrei Burkov, let's say, put it that way, that the first thing is the goal definition, not just a hype. And it's quite hard, I think, because if you think about it, like so you have a social platform, and you want to make machine learning models that's making those detect the face and make those funny bunny ears. So yeah, that's, let's say, the goal. Yeah, that we want to enable those filters. Yeah, and then you prepare the data, collect it. You are training the model, and then your business come back and say, but maybe you can make like you can make it moving, yeah, because let's say it was for the photo, but you want now you need to put it in the video, and then okay, but it's now after some time you do this, yeah, and then business comes and say it's they want actually a different thing, no bunny ears, but maybe we want to switch face for some celebrities because we get the contract with them. So the business, I think, is moving fast for sure. And I mean, the example I said is just that probably models need to be built fast, and you need those frameworks that enable you to standardize things. But also, the business actually know what they want, and they know the effect. But yeah, I guess filters on Facebook or Instagram are not really most valuable thing to have. But if you have some forecasting and prediction, like for predicting the demand for energy, probably it's quite interesting topic and important, considering the situation with the energy global wise. Yeah, and and basically that you are building products around AI, yeah, then you know what you want to have. And I think it's pretty well set up, and basically product owners are learning what they can do with ML, and there's a lot of focus on that. So I think it's quite well done, and we need to have the clear goal. We are not doing like just model for the sake of it anymore. And then we have the standard part. I think that was there for a long part for the long time. So we have data collection and preparation. We want to make some features, and I guess this is quite time consuming. So both data preparation and engineering, this is most of the time. Like I recall some polls that data scientists were asked how much time you spent on each task, like from the training, evaluation, preparation. So the cleaning was 70%. I don't think that changed much. And also feature engineering probably is quite time consuming. But yeah, also I think companies are paying much more attention to the data. I mean, it's if you don't have clean data, no, they don't bother to do ML anymore. But maybe I'm wrong. And also what's interesting, that basically we created new jobs. That was, I mean, maybe not surprising, but here it's called data labeler. So basically for data collection, we have people or like a service to, like someone is tagging that, do you see truck in this picture? Yes. Do you see someone else? Yeah, on this picture, yes. And that's quite interesting that this is actually creating jobs in that it's sign of like that this process is maturing. And also sometimes we are helping with that, you know probably what I mean, like those CAPTCHAs thing with the street lights and buses and so on. So no, I'm not a fan, but I mean, I help. I feel that if I click the right section, I'm also helping someone to maybe, I don't know, if there's a question about traffic lights, maybe autonomous cars, I think you have those in US already, but like California, Waymo or something like that. I'm waiting for that. It would be nice to sit in the car and drink coffee, and it will drive you around. I was watching Minority Report recently, old film, but they had those nice autonomous cars. So maybe someday. We'll see. I guess then we have data analysts. You can say, maybe I will make it a little bigger. I can. Okay. The picture will not get much bigger. It will just strangely swap the place in the notebook. But you can argue, because Andrei Burkov said here that it's a data analyst, but you will say, okay, but that's a data scientist, or maybe that's a machine learning engineer, or maybe something else. So I guess we still have a big problem with the naming. Like maybe it's just me. I'm not exactly sure still what data scientists do in the end. But also maybe it's getting clearer. If you say machine learning engineer, probably that's someone who now it's tricky. Model training and evaluation for sure. Feature engineering, maybe that's for the machine learning engineer, but maybe also for data engineer, but probably both. And then I guess the expectation is that the ML engineer also handles the bottom part. Or maybe not. That's ambiguous, but we have new jobs for that, and I think slowly moving to the bottom lane. It says DevOps here, and I think that's quite accurate because actually when we are trained the model and evaluate it, we are, I think, switching to the software engineering problem, not machine learning. But of course, it has its own, machine learning has more problems than software engineering. That's at least in my mind that, but like we have the deployment and serving, I guess, anything you deploy on virtual machine or like, servers has this problem that you want to control the deployments, change the versions quite, you want to control it well. And the serving, I guess, it's a big problem nowadays in the sense that, problem about we have solutions, just to be clear. So for example, like I think TikTok moved to 1 million users in some really short time, but I was trying to recall the number, but it was like months, And before Facebook took like years to get there. But so this is a problem that you can scale uncontrollably, and you may be a victim of your own success, but you know that you can like order more VMs in the cloud, so that's the solution probably. But another thing that I saw few stories that cloud is getting too expensive, and now you get those funny. Maybe funny is not the right word, but I was entertained when I saw something like FinOps, because that's basically controlling your spending in the cloud. So why did you not do this before? It's quite hard, to track it. But we are creating solutions for problems, and then we are creating problems we need to solve. So so that's how it goes, and it always was, and it will always be. Like now, this again, those new language models. We have two parties. Stop development, it's too dangerous, and the other one saying full ahead, and maybe even put more. So I'm not sure what's your opinion. I guess it's not basically this like clue of this talk, but I think this is quite an interesting like area we are going into, and we'll in 5 years we probably will not recognize the services we use and what jobs we have, so it will be even harder to keep track. Anyway, for serving, I think the machine learning has the same problems. You need to scale, just get more workers, parallelize it, and usually those models are quite like energy consuming. They are big. Like you are not deploying linear regression, or maybe you are sometimes, but there's a big problem, and some people are counting CO2 emissions instead of money, and again I was maybe that was so there were some great numbers for how much in percentage training of machine learning model is using, but then someone said, but if you are mining Bitcoin, then it's more. I guess it's getting less lucrative right now, but that's maybe another reason. That's also people will stop development because of the climate change and energy consumption. But anyway, serving you can you need basically, I guess, Docker, and you put the machine learning model there, and then you have this scalability like built in. But the things that like if you are launching a web service or website, probably you don't have a problem with those two blocks at the end. So model monitoring and maintenance. Of course, you are monitoring your app if it is a web app, but it's in case of machine learning models, it's a different thing. So basically, machine learning model degrades over time. And web apps, they don't. I mean, if you are serving, if you have an e-commerce shop, then it, in 10 years it can look the same and it will function the same.
I feel in practice they end up changing.
Like the new features, I hate that because I get used to like the old look. Like 2 days ago, my Teams got updated. I was like, okay, this will ruin my talk for sure. They are changing things, but this is, your service is not degrading, you're upgrading it, So this is different stuff. And the machine learning models, if you trained recommender systems 10 years ago, I guess you liked different things 10 years ago than right now. Or yeah, I don't know if you listened to Linkin Park. Anyone still listens? No? Okay. I was listening to Linkin Park in like primary school. And you know, and maybe the recommender model in Spotify, which was not existent by then, would recommend it, yeah, but that they need to adjust, and I don't know what it would recommend right now, yeah, like yeah. Now I will say maybe some artist, and it will not be the coolest one. Maybe okay, let's say Rihanna or Beyonce. Yeah, maybe not the freshest ones, but maybe something fresher than Linkin Park. So you need to update that, and this is a problem. Are you doing this like one each month or each year, or in streaming fashion, batch fashion? Or you actually need to track the metrics. Yeah, we had R² for regression. Still, if you have a regression machine learning model, so let's say it's a neural network, then you can still monitor R², and then if you just need to spot something goes wrong. Yeah, but how you retrain this is actually maintenance stuff. Yeah, monitoring is one thing, but yeah, I guess maybe then we are coming to the same like dashboards, like you are monitoring your infrastructure, so you just have something telling you that you have a problem, but with maintenance it's yeah, you need to switch, you need to retrain and switch your service. Yeah, and probably it would be good that it will not affect your users. So yeah, I think I sometimes was I entered some website and it gave me totally different stuff, like advertisements were different, and I was like, okay, they probably changed the version of the model. Yeah, so you probably don't want your users to notice that. Also, I'm not sure if you have the same thing, but I feel like when I'm seeing that internet, let's say in general, is affecting, like adjusting to my behavior, I feel a little uneasy, yeah, because no one, okay, like yes, maybe I'm accepting some cookies and some stuff, but and privacy, but in the end, it's really shown that I feel that everyone is using my data, and this is the new value. But yeah, you need to make it right. So this model maintenance, I think it's quite tricky. So for example, yeah, yeah, we have it in. It won't be presented this course, but we had some materials on model maintenance. You have, for example, an option to. Like, I like the names that you can switch your model following the champion challenger approach or multi-armed bandit. I like, yeah, the names are great. But yeah, so for champion challenger, you have one that is the best, yeah, and then you are training the second one offline, and if it gets better, you switch it, yeah. So they are competing for being better. But if you switch them like that, maybe there will be this problem with yeah, like transition. And the second one, multi-armed bandit is I think fancier. You have multiple models deployed at once, but the best one has higher chance of sending you the response. So if you are getting to Amazon, they are not paying me, just to be sure that just you know, everyone knows that, and we even have it in Poland. So you have if you get the response from different systems, and then maybe you can get used to the small tweaks or biases that not everything fits. And then if one of the model gets better consistently, then you can switch it dynamically, just using this probability that the best model usually, let's say, have 90% chance of responding. All other models share this 9% equally. And then if something gets better and you train it online, basically like you get the response all the time with lower probability, and then the next one can be swapped and it gets this 90%. Of course, there is more. But you know, this is something that also is developing. We are working on that, and we will totally not cover the bottom lane today and in the coming days. And I think this is, if you are using cloud, then yeah, we probably then there's a lot of stuff integrated there, and it's quite easy. But But basically, the good framework, in my mind, a good framework for machine learning should, at the end of evaluation, should allow to save the model into the file like really easily and make it interoperable and you know that backward compatible. And then deployment is actually the, as I said, software engineering stuff, like Docker stuff, and you put it in the cloud and you are happy or not with your spendings. And yeah, I just wanted to highlight that basically this is a bunch of people working on that, like from project managers to data engineers and DevOps engineers. And then probably it will, yeah, we'll just get into this more and more unless, yeah, those models will do the jobs for ourselves. So I think already there are some layoffs because of the junior programmers getting replaced with Copilot or stuff. So I'm not happy with that. You know, the jobs should only be created. Of course, it's not possible. Yeah, but we are reaching interesting. Yeah, I was always telling you will need more and more people. But in the end, it's not the. We'll see. Maybe it's not the case. But yeah, getting basically to MLJ right now. So what the good framework should provide, or maybe without a good before that. So I think we should have some easy data pre-processing and cleaning features. Yeah, feature engineering. It's actually I would say data frames should provide that, but the framework should provide ability to interoperate with data frames, and I'm meaning like data structure and in Julia the exact name of the package. But yeah, then for sure evaluation and reporting of the model's quality, that should be in the good framework, and this should be yeah. You know, reproducible, that's always a problem. You run something and forget to set a seed, you will never recreate your calculations, but basically we are tracking a lot of, yeah, there's a lot of tracking software for experiments, MLflow and everything built in the cloud. So yeah, MLJ I think integrates with MLflow, but it doesn't have the capacity for its own. But basically, that's I didn't put exactly that you should record your experiments, but yeah, I think that's part of this model evaluation and reporting that you should keep track of that. And I think yeah, tuning is unavoidable with the complex models. So yeah. So probably if we are reaching this area, then you need to parallelize it well and have GPU, because otherwise, yeah, we will build a random forest. So I will not launch, you know, a cluster with GPUs, but and two other models, not only random forest. But in general, this is really burning the money. Yeah, this is the part that is problematic. And then this deployment and serving, as I said, yeah, just you need to save it easily, retrieve. Probably it would be good also to be able to have low memory footprint if we are moving to software engineering. Yeah, so for example, sometimes on my classes I also show TensorFlow, you know, and it saves in different formats, but then you need to have TensorFlow on the Docker side. That's big, and you need to load the model. So it would be also maybe it's a desirable feature that you have something just to run the models, not all the stuff. But yeah, probably you can optimize it, but it should be easy also. Yeah, that okay, I just want to read and predict, not load everything that you have. Like Java doing this thing for a long time. You have JDK and GRA, yeah, just for run and for development. So that's how it should be. And MLJ is quite, I mean, Julia is quite new, as it was said, and MLJ must be newer because you can only create packages after the language is created. So yeah, I think it's, if you think about machine learning framework, it's the first thing that will pop up in Julia. And I just want to show few parts of this. And you will see a lot of parallels to scikit-learn. I think the most, yeah, this is the most similar, let's say, package from Python, of course, but some decisions were made differently, and maybe just yeah, I will highlight and we can think if this is good or bad. So let's see. Okay, so just let me look on the chat because we are closing this section. Okay, I'm happy we have a lot of people. So let's move on. Yeah, here. So we will, yeah, we need the data always, but yeah, probably we don't want to get like a deep dive on each feature. So I propose that we'll use the bank marketing data, and for that to see what's in, I think we can move to this bank additional names txt. Everyone loves txt, yeah. Just yeah, probably yeah. If this is short, then that's fine. And this is a data set that is obtained from the UCI repository, which is really great for machine learning, I guess. Yeah, we have a bunch of repositories, but I like this platform, this UCI, a lot, because you can pick what task you want to do, and the data sets are quite well prepared in the sense, yeah, you know, we don't want to clean for the next 1 hour, so they are usually quite good, and that's fun stuff that also you probably need to know the data sets if you are a data scientist, some specific ones, yeah, and there was like meme on LinkedIn I saw, and I really like it, that if you are going to data science interview, they should show you the iris flower, yeah, the picture of iris flower, and the question should be what is this flower, and an iris data set is probably the most popular, or one of the most popular data sets. So it's even going this way, that you need to know the data sets by heart. I mean, not to like, you know, not to remember all the observations, but I think this one is also quite common. So maybe you even know that, but let's take a look. So yeah, there's some citation stuff that, of course, we are using this from the legal source, and everything is here. Yeah, the important part is that we have information about bank clients who subscribed to the term deposit. So the setup is that someone calls you from a bank, assuming you have an account in a bank, and they call you and ask you if you want to take a term deposit. You say yes or no. Yeah, and basically that's what the data set is about. That we want to predict which client will say yes and which client will say no. We have like 40,000 observations. So yeah, comparing also to econometrics we had before the break. Yeah, then machine learning usually it's I guess right now we are talking about millions of observations, and then that's when the machine learning shines. But econometrics can deal with much smaller ones. Smaller data sets, so I think it's you know, because some people say they will only need machine learning right now, not econometrics anymore. But yeah, that's the same stuff. You can do linear regression in the ML setup, and you can do this in econometric setup, and that's the same model, but you are focusing on different things. So in ML you focus on minimizing the error. In econometrics, you want to understand the relations, so it's a little different approach, and you care about the assumptions. And yeah, so those 4 or 5 assumptions of OLS in machine learning, usually we don't care, but of course it affects the outcomes, but you care about minimizing the error. So just to have a nice link with the previous presentation, and yeah, that's interesting. That's basically the same stuff, but you totally analyzed in different way. Okay, we have 20 attributes more or less and output. So yeah, now I guess if you know the setup, if you know what we are predicting, then you can also expect something from the data. Yeah, so you're a client of the bank. Bank knows a lot about you usually. So there is like an age of the client. We have a job, which is a categorical variable. I don't think I want to even go through the classes a lot, but you know, like blue collar, entrepreneur. Yeah, like I think those are quite general categories. The interesting categories unknown, and actually this unknown will appear a lot. And the last statement in this text is that all the missing attributes are also marked with the unknown. So would be good to fill that, but yeah, it would, as I said, it's a cleaning part, and also this is quite complex. I mean, you can say, okay, fill the mode of the categorical, and in the numeric fill with the mean or median, but yeah, probably just it's better to do it right or not do it at all. So just to say what we'll do, we'll actually use the unknown as the separate category, a valid option, I hope. So yeah, also the concepts from econometrics that we have some values missing at random or not missing at random, and I like the example that if you have the population census, another nice data set from US, yeah, if you don't know this one, and people are calling you and asking, for example, for your income, yeah, like in categories, but you can say, I don't want to say. And usually if someone is really rich or really poor, or I mean on the end of those spectrum, they don't want to say. And that's not, you know, this is like a separate category, people that don't want to say the income, but this is not missing at random, that, you know, the line call breaks and then they didn't give the answer. So we actually will follow this approach that will treat it as a separate category. And basically it means we don't have to preprocess that, and we'll stay with the strings. Yeah, so basically we have some stuff related. So let's say this is socio-demographic stuff. Then we have, let's say, product related, I mean, banking product related variables, like do you have a housing loan or credit? I mean, do you have a default for a credit? So if you are paying your credit or not, and so on. Also, it's we have another section which basically says that there was a previous campaign, and there is some information from that if you were contacted by the landline telephone, I think that's the name. No one is using that anymore, I guess, or yeah, cellular. Then the second one, and when you were contacted, and how long was the call. Actually, there is a little more text here about the description. So I think this is important because it says, it's an important note, that this attribute highly affects the output. So basically duration is 0, then the answer is no, because, okay, so it works that someone called you before and you take the term deposit or not. And if you were not called, you can't have yes, because you were not called. I hope you get it. So basically, this is some processing to do. I think we should get rid of that, as the authors basically are saying, because they said that you should discard that if you have intention of building the realistic predictive model. And actually, MLJ can help with that quite easily. So another stuff like that. I don't really want to go through all of that. Maybe the last part is also relevant, because someone added the economic attributes, and you know, we are from Warsaw School of Economics, so so if there is economic variable, then and I need to say that, and actually it makes sense, because we have like employment rate, or yeah, variation rate. We have inflation index, consumer price index, and then some actually this is EU related. I think this is from Portugal, by the way, not from US. So sorry for that. But basically we have something that makes sense if you want to take a term deposit. Probably the consumer price index makes sense because it affects the rates of the term deposit. So I would say someone think it through, and we are happy that this is added. And then the last one is why. I mean, they even call it why. So target variable if someone subscribed or not. So we are actually in the area of marketing, which is quite nice for the okay, let me move it like that, for the machine learning. So yeah, we are being more and more targeted. So let's learn how to do that. Yeah. So we'll load the data into data frames. I guess that's not surprise with yeah, 40, CSV file and 40,000 rows. Probably there is not another sensible option. And we'll load the packages that we need. So MLJ for sure, CSV and data frames, like usual, they go in hand to hand if you have a CSV. So I guess nothing that you don't know. We will do some plotting, and we'll need to control the random number generation. But also there's a logging package library. This is base Julia. So yeah, MLJ, I think it's great, but it has one thing. I mean, it's not maybe the best thing for showing in front of the audience, that it produces a lot of debug messages and info messages. So we want to get rid of that, just for the sake of that we are running in the Jupyter notebook, which is not, let's say, output friendly if the output is quite big. I just don't want to flood you with those. But maybe it's a good thing to know that we can, yeah, like in every programming language, we can set the default logging level. So for example, MLJ is putting a lot of info level logs and warnings. I think also warnings are not always warnings. So I wanted to skip them, and we are actually, it means that we are disabling everything at the warning level or below, if I can say below, but you get it. Yeah. So we will get only errors. But I will highlight in one or two places where we would get warnings, but because we are running stuff in the loop, then it would look bad. So let's load the data. As usually with data frames in any language, I think it's usually a one-liner. Yeah, we just needed to switch the delimiter to semicolon. And basically, we went through all the attributes. We didn't see the exact values, but I think, we have a lot of categorical variables. We have those unknowns, which are in essence missing values, but we will treat them differently. We have some integers, like age is integer, duration of the call from the previous campaign, or if you were like contacted in the previous campaign. So there are some integers we will need to handle, but also, yeah, just to check, we have this most important one, y, which is our target variable. Yeah, and by the way, yeah, I don't remember if Przemek mentioned that yesterday, but data frames uses those strings that allocate specific memory, yeah, for string 15 for string free. So yeah, usually this is quite memory friendly, yeah, and then the data frames in Julia are quite focused on that. But yeah, just to mention, those string 3 and 15 will appear, but those are we'll just use the same functions as for ordinary strings. So this is basically it's an analogy to int64, yeah, but for strings. Yeah, and then we have a really first nice feature of MLJ. I really like, which are scientific types. Of course, this gives you an overhead that you need to learn something new that is not in other frameworks, but I think it was the right decision to do. So what are scientific types? I think the best thing is to run the schema function, and then you will see that you will have a name of your variable, and you will have scientific type and type like data type, or the types that Przemek was mentioning yesterday. So the thing is that Okay, yeah, we have data types, string, floats, integers, and many more in Julia. So you will see when we'll get to the measures from MLJ, how the types are complicated. Then I mean, yeah, we'll see. But basically, when we are switching to machine learning context, we probably want to think in different types. Like we have numeric features, we have count features. So this is a different thing, but probably continuous would be floats and count would be integers, but we treat them differently in the model. Yeah, like Poisson regression, it's for count data. So only like yeah, 1 bottle, 2 bottles. We can't have 2.5. So if we are assuming that this is a numeric feature, we are basically making a slight or bigger mistake depending on the problem you have. And sometimes we want to allow for only count, so only for yeah, whole numbers, yeah. But basically it's not, if we load the data, maybe we get it wrong. I mean, mapping from integers to counts may not always be right. And I think the best example is age here, or maybe not the best, but the first we have here. And I think, you know, we are not turning from 20 to 21 years, just one by one. We can treat it as continuous, yeah. So it would make sense to actually treat it as continuous, and this standardization will help in picking the proper machine learning models. So actually the same data types can be used in different contexts, but maybe you want to actually model the age in as a count. So in MLJ we have this distinction, but we need to sometimes fix it, yeah, and we need to explicitly say that. So that was about something working with the numbers in general, let's say, but of course we have categorical features. And here you have multi-class and ordered factor. So yeah, so categorical features can have, basically, they can be unordered or ordered, and it matters a lot, yeah. So usually I give this example that what is ordered feature, ordered categorical feature. So when you have those questionnaires, how you like something, Likert scale, yeah, I hate it, I love it, and then there's a few points in between. There is a clear order, yeah, and then this, but still this is categorical. You can't say that this is numerical, that from I hate to I slightly hate is the same distance as from I love to I slightly love, if that makes sense. Even this. So this is ordered factor. It's not as common as multi-class or like the nominal features, the unordered categorical, but again, we have those, and we can make this distinction, and they will probably come as strings, yeah. So they will all be strings, and the unfortunate part, or maybe that's the thing, that the strings by default are mapped to textual. So textual is actually for, you know, if you want to do NLP, go ahead. Yeah, I'm not sure. Yeah, Julia is well equipped for that, but maybe I didn't check well. But yeah, I think in most cases, if you use MLJ, you want to go with continuous count, multi-class, and ordered factor. So you can see that we have a lot of textual. We have, so we want to fix that. We want to get rid of textual at all. I would make age a continuous one. I hope I convinced you about that. The rest is, okay, we have a lot of features. If we not put one right, it won't be a problem. But about y, our target variable, actually we want to go with ordered factor. So we may say, okay, but it's just binary variable, 0 and 1, so multi-class may do. Okay, but yeah, we'll see. I mean, at some point I will come back to that. So actually, MLJ wants binary variables to be ordered factor because it matters which one is higher, which one is your like class number, like 1. Yeah, you have a positive case and negative case. So I will say at which moment this would be important, but basically that's what we want to do. And I think, yeah, so you have this additional complexity added because you will not do this in scikit-learn. yeah, those scientific types. But you will see that actually afterwards it will save us time with other tasks that were listed in the pipeline. So if you want to fix this, the types, scientific types, you can use the coerce function. And yeah, you can give. So yesterday it was mentioned that symbols are valid for the names of the features. So it's the same case here. You can, yeah, usually either you want a specific feature to be mapped to another scientific type, or in our case, we want to get rid of all textuals. And we'll do this in 2 steps because, okay, everything should be multi-class for textual except y, which we want to do ordered factor. So that's the next line.
Yeah. Can you also coerce, like, let's say a string that says like 3 into like an integer?
Okay, so I'm not sure if this will work automatically because you need to parse it.
Yeah.
But yeah, but for, I mean, yeah, that's I would need to check if MLJ is doing this for you, but probably it's better to just parse what you want, yeah, and then you can use it. So we basically did what we aligned to do with the changing. And the interesting part is that not only scientific types were changed, so that's probably where the question came from. Also the data types were changed. So you can see we have a lot of categorical value, which is mapping strings to unsigned integers. And okay, let's not get into technical details, but there were more technical details yesterday. But basically, the nice thing is that, yeah, actually, this is changing scientific types, which helps in reasoning and further functions we will apply. And also, okay, maybe you will say, I don't want to change the data type, but I guess it's designed in this way that categorical value will be more efficient than a string, yeah, in the processing of the data when training. So actually, I think this is a benefit. It's a feature, not a bug. And yeah, and this is defined in a separate package for categorical values. So basically, it's mapping strings to some shorter indexes, let's say some shorter equivalents, and it runs smoother than strings. But still, yeah, we have, and also, yeah, I hope you notice, but the multi-class basically also tells you the number of unique categories you have inside. Yeah, so it's a parameterized type, but yeah, you don't have to run unique, yeah, to get this. It will be shown in the schema, maybe another feature. But yeah, regarding our y variable, because this is an ordered factor, we will have ability to set the order with the levels function. So yeah, I think that was mentioned, that the convention in Julia that with the levels with exclamation mark overrides something in place. So like the structure of this ordered factor, and levels just check how we set that. Maybe it's not the best output in the sense that you need to know that the first element is the lowest in the hierarchy. So the yes is higher or like more important maybe than no. So basically, for the sake of our modeling, if we calculate recall or precision, yes will be the positive class, yeah, and we can of course switch that, like if we put this the opposite. I mean, yeah, clearly you can have the other way around, but I want to keep yes as a positive class. I mean, yeah, that's another topic that people are discussing. Yeah, that yeah, which class should be positive? Yeah, because it's not like that always yes. Yeah, make no sense. So you need to decide. And I like to tell that basically you need to pick class that you care about more, whatever it means. But I care more about people taking the term deposit. So yes, it should be positive. And usually in like in credit scoring, it's the same case. Yeah, someone give credit or not. Yeah, so probably you care more about giving the credit. But also there is a valid case to do the opposite, and I like this. It was not like I was surprised. So so usually you are producing a score, yeah, like from logistic regression and neural network as well. It will give you something we can interpret as probability, and it turns out that the managers in banks, or at least in one bank I heard about, they want to interpret it. So they want to interpret it as a credibility of the client, and yes usually means a default. So yes usually means they don't pay. Yeah, they don't pay the loan. So if you would put yes as positive, then the higher probability, which means the opposite of credibility. I don't know the prefix, but basically the managers say we want it the other way around. No problem, you can do this. So I guess maybe that was obvious, but actually you need to make this decision in MLJ. It's more or less force you to do so unless you will get warnings. So so we explicitly said that. Okay, just let me take a look again if there is something on the chat. I think it's clear. Okay, so let's move on. And teams will never learn to get it back where it were. So yeah, so let's move to data preprocessing. Okay, of course, we have quite clean data. As I said, we don't want to spend much time, and we have 1 hour left. So yeah, I guess we just want to, because the data is quite clean. I mean, missing values we discussed. Okay, we can check outliers, and maybe there would be too many categories sometimes. Yeah, yeah, I mean, probably we would need to spend more time, but trust me, data is quite clean. Let's just focus on splitting the data for training, and actually we'll also do one-hot encoding and start standardizing. But before that, I hope you remember we had some feature to some attribute to get rid of, and actually, using the data frame API, we can quite quickly check if the statement from the authors was true, and the statement was that whenever the answer was if the answer was no for the previous campaign, someone calling you and asking about term deposit, it may also indicate that there was no call. Yeah, so it may be 0 here, and it's visible if we take those simple statistics. Of course, I could use describe on the data frame, but I just wanted to get it exactly what I wanted. So we can see the 0 is minimum value when the y is no, and basically we can also count it and so on. But this is true. Yeah, if the answer is yes, the call was never 0. I mean, you will. Yeah, you don't pick up the phone and say for hello, I will take the term deposit, and it won't be 0 anyway. So we want to get rid of that. But actually, in MLJ, with MLJ, we can do this while we are also when we are preparing for the modeling. So we can see we are producing y and x, and now we are getting back into the scikit-learn area where the authors, and I think that was nice decision or the standard that basically when you want to model something in scikit-learn, usually you split the data into dependent variable and regressors or independent variables, and usually you call them y and x. So that's exactly what we are doing here. And for that, we have the unpack function. So it's quite interesting. It takes a data frame, I think some other data structures would be compatible too, but basically it's all tied to data frames. And then you can give as many arguments as you want, and basically it should be a selector for the names of the variables. And in the end, the last thing you get will be the remaining columns. So I'm not sure if this is clear, so let's go through that. So basically you give a data frame, yeah, which has a lot of columns, like 21 I see here. And you say, okay, so the first thing I want you to return is just the column Y, and then remove it from the data frame. I mean, that's the default. You are picking this up and putting this as the first output. And then you say, okay, so I have a target variable already returned, and then give me everything except duration. And you can put 5 more, 3 more, no, doesn't matter. You will get, you basically are slicing this cake from above, like the columns, yeah? So let's check if this is actually what happens. Yeah, at first it was, at least for me, it was not really intuitive, but in the end, yeah, it's quite nice feature, I think, because you can cut it into multiple pieces without like boilerplate code and some additional lines. So yeah, Y is just a categorical array with no NES, and X is regressors, our independent variables, and you can see we have 19 columns, not 20. So duration was actually removed. I think we can check the names. Yeah, I will not do in, but scanning, I don't see duration. By the way, was the pipeline syntax explained yesterday, or not?
I don't think so.
No, okay, which is really nice. I mean, the pipeline syntax, but yeah, also I think, yeah, I just let's say make a spoiler. Let's say there is something about, yeah, I will use it later, but basically this is equivalent of names X, yeah, the same thing. So usually you should pass the functions with one argument. You can, but yeah, you can use functions with more arguments, but then you need to care, you care about the order. So it's built in Julia, this pipeline syntax, and it's really nice in the sense that maybe it's only me, but I usually forget to put the function I want, and if you want to, yeah, if you put X already, you would need to get back to the start, yeah, and put it the name of the function and parentheses, and also it would get, you know, it gets problematic if you do something like mean around combine around group by. And then those parentheses, you get lost in them. At least that's a problem with the syntax. It's a little cleaner. Okay, so we have X and Y. Duration is gone. So we'll clean it a little. I mean, preprocess, maybe not clean, because it's not to be honest, cleaning. We are just preparing this for machine learning. So yeah, I'm not sure. I always had problems like with what's the distinction when preprocessing and cleaning like ends, or where's the distinction? And I usually think about it in this way. If you clean the data, you can do this both for machine learning or displaying in the dashboard. And if you preprocess, you want to do this for machine learning explicitly. But of course, you know, it's my just how I think about it. So it's all preprocessing, right? But basically, usually we want to standardize the numeric features or normalize. We want we for sure want to one-hot encode the nominal features. So no, with ordered features, ordered categorical, actually we want to keep the column, but we need a model that can handle that in most cases. And yeah, of course, we have imputing the missing values, transforming skewed. Probably we want to collapse some classes if there is too much of those classes, or there are not many like the count of the class is low. So for example, if you have a country of nationality, and there's like probably in US census, yeah, and you have a lot of US, a lot of other citizens. I mean, yeah, I guess they are all citizens, but nationality is different. But you have probably some nationalities that have like like, 0.1%, yeah, in the sense. So probably it would be problematic to use this low number of observations. You want to probably collapse it, and usually there is this nice placeholder called others. But this is sometimes it needs some more like business context. Yeah, like if you have countries and you have a low number in some particular countries, then you can collapse into continents. Yeah, something like that. Yes.
If we wanted to have dropped a column besides just duration, like, I don't know, age, how would we do that?
So like more than one? I think we can use in and the dot operator, and then you can give the list, if I'm not mistaken, or you can give a function actually here. So just to make it, yeah, or anonymous functions here, yeah, and then you can say like your x. Not yeah, actually you would need, are they negation, or yeah, you can steer it. So yeah, you can give a function here. But let's get this to the usual state. Yeah, so this is quite convenient for one of the, like, if you have one name, but if you want to have multiple ones, then you need to somehow either in with the dot, so you will vectorize it, or yeah, lambda function, yeah, anonymous function. Okay, let's call it lambda. I know it's from Python, but or actually in Java also, but the easiest option is always to use the anonymous functions, and then it's yeah, you're 100% sure, and you are not adding much to the code size. Okay, so there's a lot, like a bunch of transformers, because I think that's the same name in scikit-learn, and MLJ follows that. So some yeah, process part of the pipelines, yeah, some objects defined in the MLJ that can help you with the pre-processing tasks. But we will use standardizer and one-hot encoder, probably like two of the most used transformations for the one for the numeric features, the second for the categorical ones. But actually, to do that, we need to dive a little deeper into the MLJ interface, let's say. So yeah, just regarding standardizer and then one-hot encoder, of course, it works with the, let's say, help syntax that you can get more details what it does. So standardizer, yeah, I guess you know both. So and we'll see this in the effect of how it works. But basically, both action standardizing and one-hot encoding help with building ML models. Some models basically do them underneath. You don't even know, but probably doesn't hurt to do this by hand. Yeah. So the nice thing, if we are in the standardizer help, you can see that this works only for continuous features. So now it pays off. You set the continuous features before, it takes some time, but now you can run standardizer without giving the names of the features. Yeah, it will pick up the continuous automatically. Actually, if you go into the details, you can also include count. And you can also give a list of features to ignore or features to include. So it's more complicated, but if you spend some time on preparing the scientific types, you probably are saving yourself in the rest of preprocessing. And we will use one-hot encoder as well. And I want to maybe move to the code. It will be a little clearer. So actually, if you look here, we have transform and fit, and that's look like scikit-learn for sure. Yeah. So maybe with fit without the okay, it would be a method in Python and without the exclamation mark, but basically I think, yeah, that's also a nice interface that you basically you can use transform and fit, and any object you put, I guess. Let's say we agree that this is a good design decision, and I think the frameworks they need to make those decisions. So actually MLJ went also a little. They added one more abstraction for sure. So there's a machine. I like the name, and basically machine. If it's not that easy to you need to run a few things to maybe understand it better. But I like to say that this is tying the data to some specific algorithm. So it can be a machine learning model or transformer or pipeline, because we can construct pipelines easily. But basically, I don't think there's equivalent in scikit-learn, because you have an instance of a class, you use fit and give the data, and here you give data first and then you fit. Okay, you can say maybe why is that for? So I think mostly it's for reusing the data, yeah. So that it's optimizing the some things. So if you want to rerun some algorithm, maybe this machine abstraction will actually say, okay, I'm skipping some part that don't have to be run again. But you just need to, basically everything is based on machines. So you actually, if you want to use MLJ, you need to use this concept, and there's no way to get around. And actually we are using a lot of MLJ concepts here. So we are using standardizer one-hot encoder, but putting them in pipeline, and this is the same exact pipeline syntax that is in base Julia. So we don't have like the scikit-learn stuff with make pipeline, I think that's called. So Julia like aims to be modular, and then we are just tying those parts together. And then we are creating machine for the pipeline of transformers, tying this to the data. Then we are fitting this on the data. So you can see that fit is actually not taking any data, but then transform. We are transforming the data that was used to train both of those transformers. Yeah, when I say transformer, I always get those big robots from the film, but yeah, that's the name they have. And it looks like it's good. Yeah, age doesn't make sense to us anymore, so it's standardized. We have a lot of new columns. So we had 19. We had 19 for regressors, and now we have for independent variables. Now we have 62. So we can see one-hot encoding works if you look on the name. So I think one of the bigger problems with one-hot encoding is how to name the new columns. I like this approach. So name of the feature underscore and the category name. Of course, there is an option to change that, but basically, yeah, I just want to make sure. Yeah, looks like everything works well. So yeah, those are standardized. We have standardized numeric features. We have some counts that remained here, the integers, and we have a lot of one-hot encoded columns. So yeah, I guess if you have many, yeah, so that would be part of preprocessing. If you would have thousands of categories, probably you don't want to one-hot encode them all. Maybe you want to collapse, but yeah, we have 40,000 rows, so 62 columns doesn't hurt us. In econometric setup, it would hurt us a little. We don't want to add a lot of columns, because then we get like we can't solve the equation system. But yeah, here we are basically ready, and we can yeah. So this is the same like the same agreement as in scikit-learn, that basically those are not machine learning models, but you are fitting them, and they have some parameters that were learned. Of course, those are not ML parameters, but for standardizer, for example. So maybe if I do a fitted params for the whole pipeline, this is actually this is a machine, yeah, that is wrapping the pipeline. So unfortunately, we need to use those notation and take some time. But we have one-hot encoder, which is not really interesting, I would say, because it just saves the names of the categories and doing some optimization with the indexes here. So I think it's not that, it's not actually the index, but it translates strings into those smaller values based on integers. But if you look into the standardizer, what standardizer should hold? Mean and standard deviation for each feature, yeah? So it's there, and that's what, if you have new data, you need not, I mean, you don't need to use this one, but probably that's the right way to go. If you have new data, you want to use standardizer from the training data. And if you don't want to check mean by using describe, then you can also read it here. So yeah, I guess that's it. Hmm?
I mean, standardizer just makes it have like variance for, but it had like a very non-normal distribution. You still have like a non.
Yeah. Yeah, that's a problem. So then you probably need to do some transformation. Yeah, like I think yeah, like skewed. Yeah, I forget the word. So if you had this skew in MLJ, there's like a Box-Cox transformation, which is basically like a logarithmic transformation, but more elastic. Yeah, so then it's getting harder, but yeah, you need to analyze it more. So yeah, you are right. Standardizing is not that easy that you can always do this out of the box, because it can also, it doesn't necessarily help your model, but yeah, also there's more in MLJ. So if you are interested, then yeah, or you can even write your own transformer. Yeah, so of course as I said, Julia encourage putting your own stuff into the framework. So it's all there. Valid point. I didn't check if everything has a normal distribution, but we'll see what is the area under the curve later. Okay, so that was the preprocessing part. So again, I will take a look on the chat, which is, I don't see any questions, so let's move on. Yeah, and then we have some interesting design decision. So in scikit-learn, basically you have the implementations of the models in the package, yeah, in sub-packages or modules, but MLJ actually doesn't implement the models itself, but it makes it depends on other developers, other packages that they will implement the models and make their models compliant with the MLJ interface. So actually, you will not find, like, you can't load those models directly from MLJ. You need to find the model you need and then load it actually with just the package where it was originally implemented in, or some special packages that are this like glue between the MLJ and the models itself. So actually, yeah, you know, we can check the repository and pick something, but I already picked for us a random forest linear perceptron, so a simple neural network, and the decision tree, which is called Evo tree, so with some specific implementation. So we'll get one from decision tree package, one from Evo trees, and one from BetaML. So models from packages loaded with MLJ to use them. And I think it's quite interesting decision with its pros and cons. But basically, if you want to search for the models, you have a function called models, and if you call it like empty, then it will take some time. Maybe it shouldn't. Basically, it should give you all the models that are available in this registry. So I can see 226. So it's growing. It's growing comparing to the last number I remembered. And basically, it's like a metadata. Yeah, there's just information about each package, and you can see like you can see the package names. So basically tells you which model comes from which package, and this is like a unique key, because sometimes there are the same model names, but from different packages. So just the model name is not sufficient. And you can see that there's scikit-learn is appearing a lot. So actually MLJ, yeah, there was a talk about integration with Python and MLJ. Actually, they changed it some time ago because there was a different package for scikit-learn, but now it's basically MLJ integrates with scikit-learn interface, and you can get the what you can get. You can get an AdaBoost classifier and other stuff from Python. Also, there's XGBoost, and actually this is a XGBoost package that is implementing I think it's quite famous and actually good model for tabular data. But also we can have models that are implemented purely in Julia, so they are not just an interface to the Python stuff or some adaptation. So I think decision tree, for example, is a package that is written purely in Julia. But actually, we don't need to guess. We can so you can filter this this registry. I think if I give I just wonder if I need to give just a function. Okay. If I give m, and that m is pure Julia, okay, yeah, I need to give a lambda function. So 118 models are actually just written in Julia, which means that they are not using PyCall or rcall or anything else. If you care about it, I mean, if you ask me, does it make sense? I guess there is an overhead to call scikit-learn, and you need to set up this scikit-learn and some other dependencies. So maybe it's yeah, depends on the case. And I think the problem was that as with every new language, that you need to implement everything from the scratch. Yeah, and Julia actually enabled to use something. Yeah, scikit-learn is great. Yeah, and you can use it. But gradually, maybe that's some area to improve. If you want to have your package here, then you can implement those models, more models in Julia, and they will run faster, assuming your implementation is as optimized as scikit-learn. They are usually quite good. So yeah. So this is just a matter of preference, maybe. But also, I think the important thing is this matching function. So you basically say return the models that will take as input our independent data and will predict the target variable. So basically it means using this you will only get models that can process all the scientific types you have and will do the task that you want, and you didn't specify the task. So we didn't say we want to do a binary classification, but basically, if you take a look on what Y is, it's a categorical array. So you will not do regression on categorical array. So that's why it was important that those types are set right. Yeah, and basically, with this, as I said, that's another benefit we reap. Yeah, from setting the scientific types right, and you can see, okay, I want models that will fit this data to predict the Y vector, and I want only pure Julia, and I get 14. Okay, so we limited ourselves a little, and yeah, actually, so we could have probably run all of them, but you can try. I just picked arbitrarily. I think yeah, one. There's a lot of decision trees, random forest. You can see, for example, here, random forest classifier is actually from 2 packages here. So it wouldn't be sufficient to just give the name. I don't know. Okay, I will need to check those new models I see here. But basically, we can pick from that. And yeah, let's pick those 3. So what after you are decided which model you want to use, you still need to load them. So as I said, it's still a separate package. Models are implemented in separate package, and you need to do basically using or import. And yeah, so MLJ helps with that a little. That you have this load. Yeah, you have this load path function, and you are giving the model name and the package name, let's say unique key, and it's loading it for you, assuming you have them installed. So that's if you look into the project Tom, I hope they are there. Like BetaML, yeah, we have BetaML. We should have decision trees, no, Evo trees, and something for random forest. So basically, when you run instantiate, you make sure you can load them, and now you just load them with this function. So nothing fancy, but this is a little awkward, yeah. I would say in scikit-learn it would be smoother, but I guess there was no other way around. I guess, okay, there's another way around. If you load all the models, but then you load 226 models when you use using MLJ, and people will not be happy with that. Sorry, load path is just for showing the path, and actual loading is with load macro. So this is you can see it's actually saying that it's importing some package, but yeah, so there's a little complexity here that those authors of models, they can decide, okay, I will just use my package. So this Evo trees and BetaML, those are the packages created originally by authors, but I can also integrate a little more with MLJ, and you can see here it's MLJ decision tree interface. That's the exact name of the package, but actually the model is from decision tree package. So it's just a glue. It's just a glue that enables you to do more. Yeah. So actually, there's more complexity on developer side, I think, and developers can handle themselves in Julia usually. So that was the model repository. Yeah, and that's another part. So I will take a look on the chat again. And you know, we have half an hour. So finally, we are getting to training and evaluation. So yeah, it takes some time, but I think we basically covered, let's say, the biggest novelty compared to other machine learning frameworks, and now we'll have, you know, you can pick cross validation or holdout, which will split the data into two subsets, and there should be some interface for hyperparameter tuning. So let's see. Yeah, I just run another data frame check, maybe a matter of habit that I wanted to check if we have a balanced data in terms of the target variable. So we can see usually the category that interests us more has less features. Like people are usually paying their credits. People are usually not getting the term deposits unless you are always accepting. But you can see we have like 10% of the, more or less 10% is they accepted the term deposit. So we have imbalance. I guess we shouldn't use accuracy as our metric to evaluate the models, but I guess people are not using accuracy a lot. Yeah, so we'll use area under the curve, which is already loaded for us. So we'll get to that. Yeah, let's move in order. But MLJ is giving you the metrics. You don't have to implement them. Like in scikit-learn, there's a metrics also module. Okay, so we have picked the models. We have preprocessed the data, but we still didn't. We didn't make two subsets: training and evaluate, or maybe test would be needed. But yeah. Actually, for sure, we need at least two. I just want to show, because there are other options more convenient in MLJ, that we have unpack that was cutting like from above, and we have partition which is doing the same as test train split. Yes, so it's cutting by rows, let's say. And yeah, I think you can see the resemblance. Like, yeah, we are giving X and Y. we are giving, yeah, this is by default percentage of training subset, and yeah, we have some RNG to control as usual. So I don't think we need to focus on that. This is really similar to train test split. But as I said, this is one way to go if you want to control the split manually, which is not like, depending on your setup, but probably you maybe want to say, okay, I'm giving you the data, but and divide it when you are training and evaluating with 80% in the training. So actually, we will do this with the holdout object. But I just want to go a little, let's say, step by step. So we are splitting the data. We are doing a machine. So yeah, we are creating the instance of the random forest. And tying this to the data. Looks like fit in scikit-learn, but fit is actually on the second line. Yeah, I guess this output is not. Yeah, I don't want to comment that there's some output, and I guess when you trained the model, you want to predict. So. So there are some functions, yeah, for that yeah, like predict mode, for example. So this will give you like it will classify. Yeah, it's not a score. It will give you the prediction with the higher probability, because we are still we are using random forest which is capable of producing scores. So it will just give you the final classification. And yeah, so we can okay. I said accuracy is not a good metric, but I'm using it anyway. But this is just to go through the steps, and just I just want to mention that. Yeah, we didn't load it. We didn't define accuracy for sure. Our own, we didn't load it. So basically, all those metrics, they are loaded for you using MLJ. So if I put accuracy or ACC, yeah, then it's quite easy to load it. I guess we can use like AU will give you AUC, maybe precision. Yeah. So basically, it's loading this into your space. Namespace, especially.
I think you can achieve the accuracy by just always saying.
Yeah, it would be quite high, because there's majority is no.
Yeah, it's 90%.
But that's basically percentage of those. Yeah, so that's why accuracy is quite bad, but it's it's high. So it's yeah we'll switch to AUC. But I just wanted to comment that it's convenient to have those. But if you are defining your own accuracy or your function of the name accuracy, then this can be sometimes an issue. Yeah, but I think to keep in mind that all those metrics they are loaded, and yeah, probably we have multiple dispatch in Julia, which is nice. So you can have the same function, with the same name, which was defined multiple times on different types of arguments. So actually, maybe it's not that a big issue in Julia with covering the names. But I'm actually covering the name later just to show that. So yeah, let's move on. I want to evaluate those three models we have. And actually, I'm covering something that MLJ loaded for me, and it's called measures. So measures is like a repository for measures, but it works the same way as models we have. Okay, let's give it some time because it's training the perceptron, and this is the last model. Okay, so basically, yes. So here we made four steps, which are like, I think, quite explicit in the sense that, yeah, we can maybe automate it a little. And actually, we are shortening the process here. So you can see I'm using this the split variable, and the holdout is basically doing the split for me inside a function. So right now I am not using those subsets I created before. I am using the another abstraction from MLJ. Basically, we can define the resampling objects. Probably, usually you are using cross-validation, but holdout is just a usual subset creation, and I think it's quite nice. One function called evaluate. We know what it does. So this is evaluating the model, but actually it's training and evaluating according to some specification. Maybe I went a little too far. Like the model is called M because we are looping between random forest, the decision trees, and linear perceptron. But then so what you need to train and evaluate? You need a model, you need the data to fit on, and you need resampling strategy because on one part you want to train and on another one you want to evaluate. If you are using cross-validation, you are doing this basically multiple times, but in the end, and you need a measure, and you need a measure. Yeah, so you need to train, you need the data and the model. You want to split the data into subsets, and you want to evaluate on the validation data set or test data set, however you want to call it, with some specific measure. So that's what we are doing here. And I think it's quite easy. Basically, this one cell is doing those 4 before with actually 3 models, not 1. And we want to check accuracy, area under the curve, and F1 score for 3 models. And we are sampling 80% of the data into training. And actually, I don't want to save the models. I'm just printing the results just to show you that it's actually, I think, working quite well. And what is the best one? Accuracy for sure is not a good measure, but linear perceptron is winning. So I think I think I already said we'll use area under the curve. So probably I should pick the Evo tree classifier, which has the highest value on the validation data set, but we'll pick the random forest because it has a lot of hyperparameters for tuning. Yeah. So yeah, of course, we are not we are not actually picking the best one model by the book, but you can see that this it's about learning those abstractions from MLJ. Actually, if I run measures right now, just without MLJ, yeah, it's not working. I break it because measures is 3-element vector. So I overwritten the one that was imported, but that's not a big problem. I can always make a fully qualified name with like package dot and the object from the package. It can be, yeah, let's call it an object. Sometimes if you are importing 2 functions, I mean one function with the same name from 2 modules, then I think it's quite nice in Julia. It will tell you that you are shadowing the variable, the name, and yeah, I think you can control the behavior. So either it will shadow, or you will not import that, and you can always use a prefix which is explicit. Yeah, in Python, yeah, I guess everyone, if someone's working with Python, you get to this point when you are shadowing your functions and you have a problem. For example, yeah, I once worked with a code when someone imported everything from NumPy, and the sum function. The worst part was that the sum function was actually working a lot of time because there was a lot of compatibility with the base one, but at some time it broke. So it was a production code. So we don't want to cover the namespace. Yeah. So in Julia, I think it's quite explicit. If you anyway, importing everything from a package is, at least in Python, is not recommended at all. But in Julia, that's the default because we are for some reason we are usually using, but also there is import, which is then, you know, like in Python we can get a specific, we can get a whole package, yeah, but we still need to use a prefix, or we can get a specific things, specific objects from the package. Just a matter of taste, but it's working quite well. Yeah, so measures, we have 55 measures, like we had 200 something models. It's quite nice. You can quite easily search it, like let's put error and let's see what happens. So yeah, I'm not entirely, I mean, we can check the docs, but it's scanning the name, it's scanning the documentation of the metadata and aliases. So this is some, let's say, well thought regex that you are doing there. But if you're looking for an error, you can see that 12 entries make some sense, like probably root mean squared error without log. This is for regression, of course, yeah, but if we want to do classification, entropy, let's try, okay. Okay, it's quite then log loss, yeah, Breyer loss. And in classification, you actually doesn't have a in regression, everything has name error in name, yeah. And here I would probably, if I put SEC, I would get a lot. Yeah, it's yeah, probably I was hoping for accuracy, but yeah, let's try accuracy actually, and let's see how much we get. Yeah, so yeah, we have one for multiple targets, accuracy. We have balance accuracy, which is actually, I think balance accuracy is it's a lie because it's actually a weighted recall, if I recall correctly. But you can check the details, like actually, why don't we check the details for balanced accuracy? So we actually, it's just a dictionary. Okay, doesn't say much, but yeah, you can dig deeper in the documentation, I think. So okay, actually, the documentation is the next step I have here. So let's try this one. So this doc macro is just convenient, maybe replacement for the question mark. Basically, question mark is switching to the help mode, and doc macro is doing a little different stuff, but it returns the same thing basically. Return a callable measure for computing the balance accuracy. Okay, thank you, but balance approach. Okay, so you have some paper to read in the docs. You know, that's usually, yeah, all this stuff is done by researchers. So there is a little more. Oh, it's going us to Wikipedia. Okay. Let's not get distracted. But basically, those docs in MLJ is another stuff that they are really good usually, and you can just read them, like, yeah, they're like a lot of references, and then you go to one, you know, and then you go to the reference from the reference, and you get lost sometime, but everything is there. So those measures is, you know, I think it's quite convenient that you can use them out of the box, and you can put your own, as I said, that's a part of the MLJ, that this is modular. But yeah, then models, metrics, let's go to tuning, yeah. So let's see how it works, because actually we just did like a single step training and evaluation of accuracy, then we do this holdout stuff, but actually I want to train something maybe a little better, like properly. Okay, so as I said, yeah, actually the text is not right because it says that the random forest classifier achieved the best area under the curve. So I guess my random set was not enough, but yeah, let's say we are using random forest classifier for later. Of course, you know, in the proper setup, we would tune all the 3 models, probably maybe even 14 that we matched, but we don't have time, and I don't want to kill my Mac. So yeah, let's just get this forest and with some seed. so this is a random forest, and yeah, you know the model. I don't want to go into details. Basically, this is a nice model for tuning because you have like, yeah, multiple hyperparameters. So of course we don't want to tune this like 8 dimensions, but we can pick whatever you want, and we can have a nice example of tuning. I guess this is okay. Scikit-learn names. Yeah, a lot of resemblance. So let's not focus on them. But again, you can check the docs in the yeah, and you have another let's say paper in paper. So actually it's quite good because you know what is the original paper, and usually it's hard to find. So maybe that's a thing. Okay, so this would be actually the last part with the tuning. So let me check the chat. I'm happy there's still a lot of people there. And yeah, so you probably won't be surprised that it will look like scikit-learn. But if something is working, why not? You don't have to reinvent the wheel. Yeah, and there's a lot of text. Let's go into the code. So and this is from scikit-learn even. So I think this is a nice explanation of cross-validation. Actually, they messed the colors if you look on it closely, because the test data on the bottom should be blue, not orange, because that's the same. And the training data, anyway, it's a little misleading, but it's showing nice that we are basically iterating over the faults. Yeah, let's not learn over cross-validation here. You know it. But I want to see the like the process. Yeah, it should be quite straightforward. I mean, in scikit-learn we can do this in one call. Yeah, or like we are setting up the parameters and then running just one function. And here we will use tuned model. So that's a way to go with for tuning. And in tuning, basically, it's quite similar to evaluate we had before. So what we need? Yeah. We need a model. We need a resampling strategy as before. But yeah, usually, I guess it's still valid that proper tuning is with cross-validation, not another resampling. I guess maybe, yeah, we can say stratified cross-validation or something like that, but then it's specific to the case. So we have resampling, we have still a measure or measures, but for tuning we are adding two parameters, so tuning strategy and range over which we want to do this. Yeah, so the most common tuning strategies are there. So grid search and randomized search or random search. There's a little more like some Latin hypercube search, yeah, but let's not go into details. And I guess most people still use grid search, or yeah, if you have a lot of CPU, then you will switch to randomized search and run until your budget is gone. Or yeah, I don't know. Maybe I like grid search because you can visualize the data on heat map. Yeah, you have the even spacing of the hyperparameters. And okay, let's say that we want to tune 2 hyperparameters. So the number of trees in the random forest, it will go from 10 to 80. Makes sense. I mean, it's a must-have for grid search that we will specify the boundaries, unless there is some natural ones, like like percentage from 0 to like subsample. Yeah, it's going to go from 0 to 1. Okay, 0 doesn't make sense, but something close to 0. Some subsample of the data set, and yeah, we are going from 9 to 80. We know that more trees makes more running time and training time. Yeah, so probably we want to have as much as we can, but when it's not making a difference, number of trees, we want to cut the number. And then we also have max depth, which is maximum depth of a single tree in the random forest. Yeah, I guess 1 doesn't make sense because that's just a root if it's counting this way, but we are going from 2 to 30. Just an arbitrary decision. I guess you know how it's usually picked, that you just check different values and limit it as much as you can into the area that actually makes sense to search. So yeah, I checked what makes sense, and I thought that those are the good numbers. We are not giving the resolution of these ranges here, as you see, but actually we are giving this to the grid search strategy. It's called grid in MLJ, and then the default, yeah, probably that's the most important parameter, the resolution of the search for each dimension, of course, yeah, because that's the resolution. Also, that's quite interesting. I mean, you can set a goal parameter that will amount to all all iterations you want to do, like the number of iterations. But then MLJ will try to find the right resolution for you. But I guess people, yeah, I would rather control the exact numbers. If you want to, probably you want to split them unequally sometimes. So in this case, you can override the default resolution with just a tuple. So the range would be first element of the tuple. I can put 5 here, and it was around 5 instead of 6. So of course, there are a few other setups you can do. So for example, maybe that's also interesting that you can give the same parameter twice with different lower and upper bounds, but you can change the resolution. So it's like you can condense the resolution in some area and loosen it in the other. But yeah, that's I think the proper grid search specification. So the range for the hyperparameters goes into range parameter for the tuned model, and the tuning is just a specification of the tuning strategy. To be honest, yeah, looks like scikit-learn. Exactly. So we can pass this. We are passing area under the curve that was loaded from MLJ, and then what we do is we are creating a machine and running a fit. Yeah. So the standard interface let's say MLJ is providing. Actually, I think I missed it when I said before that when you are tying data to something in machine, I said, okay, pipeline, model, transformer, but it also can be the tuned model. I can expect that anything that will be added to the MLJ and it will be a wrapper around models, it will be wrapped in the machine at the end. So I think that's quite clear. Okay, I should have run it before I was explaining. You know why? Probably, yeah. So we are evaluating 36 meta models. So yeah, it's just models with different configurations. Yeah, so makes sense. Yes, so we have a resolution of 6 two-dimensional hyperparameter search. So 36. Actually, every model is also run with the 4 times because we have 4-fold cross-validation. Yeah. So I think if I know maybe you are tired with those comparisons with scikit-learn, but I think in scikit-learn it will give you the number after the multiplication. Yeah. So I'm not sure which one is better, but the thing is that for sure it's taking some time, and to give it some time, let's let it calculate. And then we'll plot the results. Yeah, so just let me check. Okay, we have 1 minute. So I totally should have run it before, but okay, the plots should be the same. So let's start them. I hope that the random seed is working. And yeah, I guess what's the output of tuning? So you basically get the best model. I guess that's the immediate output you want to use. But also maybe it's interesting to see how the measure was changing in the dimensions. So I said, yeah, we can produce a heat map, or you can use the default plot. So this is This is the overloaded plot from the plots, yeah, but it's taking the machine from MLJ. So this is this modularity part. You are tying different parts of the ecosystem. Maybe they should work on the names on the y-axis, because if you, I can't check it because it's blocked, but yeah, that's the type of the area under the curve, but it's quite big. But basically this says area under the curve here and here. Yeah, I guess we are as expected with the increasing number of trees, because here on X we have number of trees, on Y we have max depth, and they make the layout nice that basically, you know, up on upper plot is for number of trees, the right one is for max depth, so they are like a cross section. But as expected for number of trees, the area under the curve is rising. First sharply, then it's stabilizing. I guess we can try a little more, up to 100 or 200, but yeah, as I said, we want to find where it levels off. Yeah, not levels off, because it was, yeah, so when it's get like this, yeah, and we are not really interested to increase it much. Actually, sometimes if you increase the number of trees, you will worsen the performance, but it depends on the data, at least. Yeah, it's not always the case. Actually, for max depth, I would expect a U-shape relation, which is, you know, like overfitting and underfitting on sides, and actually it's happening a little. So when the max depth is too low, we have underfitted trees. Yeah, and you can, if you look closely on the right, there's a slightly overfitting between 25 and 30 in terms of depth. So probably we want to cut around 25. Of course, we would need to make a more exhaustive search to make it right, but yeah, we finished for the 36 models. So I just want to show you type of, if I didn't forget about this, type of area under the curve. So this is the stuff that is appearing on the y-axis. So yeah, maybe if you want to fix something in MLJ, make a PR. But yeah, actually I think it was good, then it's broken again, or yeah, it's AUC, and yeah, and we basically get the results, I think, as expected in terms of overfitting, underfitting. So let's just see how we can extract the best model. You get the parameters from the machine and extract the best model. Actually, this gives you the instance. So now, with this best model, you can do, like, you can predict the mode. You can evaluate it again in for some other measures. So yeah, it's working quite well. I think we have area under the curve 0.792, and before we had just the fast one. Okay, so we had 0.782. So we increased it a little with the tuning. Still worse than Evo trees. Maybe they make them better. But I think in the end tuning worked, and we obtained the model. We can make a predictions, and just to wrap up, we can save the model with the save function. But yeah, I think, you know, you need to cut the presentation somewhere. So yeah, this save function, you can try it, and then you probably will save it into, like, there's a Genie framework for web servers if you want to wrap it, but then we would get into the bottom lane from the first diagram. Okay, so sorry for keeping you a little longer, but I think that's it for today. So do you have any questions? Okay, so I mean, we had some questions, so I'm happy, but I guess it was clear. I see on the chat that also it's clear. So thank you for today. Yeah, and see you on the next day.